you have two options here, the max rate and the back pressure, right? So nowadays, it is actually very easy to spin up a streaming job and just get the data and then do something about it, right? Because there are so many APIs available to bring it up. But to take it into production and then make it stable, that requires time and effort, right? So you need to know what is the maximum rate your streaming job can take care, right? For example, you have like 10,000 events per second, and that's a happy path. And suddenly, the upstream systems are down, and you get all the data one at once. So here now is the case where you have to process 10,000 records per second. Then that's when you need to know what are the capabilities of your streaming job, right? So it's kind of a load testing, but at the input side. So that's how we're trying to understand here, right? And the back pressure is basically you can control the amount of data you read, and you actually so who controls the data? That's taken care by the back pressure. Right? Sometimes you can actually get the data, store them at the Spark side, or you can not get the data but hold it at the source side. So you need to know exactly how you are using that config. That again is based on the source you are trying to conform. The next point is the parallelism. So this is one of the very important aspects here. Now you set up the basics streaming job. You took care of the input rate. You got the checkpointing right. The next point is how can you scale, right? Now the scaling part is it's the ability to read the data from source in parallel. So by default, all of the frameworks you choose will have a one-to-one mapping between a streaming framework's process and the source partitions. So what exactly is a process, right? So a process is basically it's like a JVM process. So people who are familiar with the Spark streaming, you can think of it as a executor. And if you're coming from a Storm world, it's again actually a worker process, right? The namings are different, but eventually it all boils down to a JVM process, right? So there is a one-to-one correlation between the process and also the source partitions, which is here the Kafka partitions, right? So that's what it is, right? The Spark's executor, and if you're using Storm, like the Storm is having spouts and bolts. If you're not familiar, it's okay, but it has spouts and bolts. Spout is more about the sources, and bolts are like the ones which actually does the work, right? So that's the mapping here. Now, there's an extension to this is you actually read the data from the source, right? And sometimes you can continue with that parallelism to the next phase, which is the process, or you also have the ability to increase the parallelism at the next stage with this process, which means that you have one-to-one. You have like 10 partitions in the Kafka side, and you have 10 executors to, or you have 20 executors basically, right? So the maximum parallelism you can only get is one-to-one, right? You still have 10 more available. You can actually reshuffle the partitions and increase to 20. But at this stage, you actually have 20 partitions doing all the things parallel. But before you actually reach to that stage, you are doing shuffling of the data, right? So that increases the network latency. So you need to take care of that thing if you wanted to increase the parallelism. So that's one of the takeaway here. And the next step is the stream processing. So the main decision point here is knowing whether we are doing a micro batch or a continuous process, right? So this will define how you are taking care of the resource connection pool caching, the connection pooling for database interactions, right? So most of the times what we do is you have a streaming job and you wanted to join that streaming job maybe with some metadata, the static metadata, right? So at that phase, you also need to define how frequently that cache is actually refreshed and how to keep it updated and how much can you actually store, right? So those things will be defined if it is based on the micro batch or continuous. Because if you're saving something to a database, you need to know how many connections are you making, because you can make as many as you want from the processing side, right? But at the end of the day, the database won't allow more than few, right? And you need to know, so that's what the connection pooling is there for, right? So at which level do you actually design your connection pooling? That defines based on the use case you have, right? And then at the next, I wanted to explore what are the different types of use cases you would be having, right? So the first one is basically analytics. By default, analytics means you're doing something for the last one minute or so, which means you're waiting until 1 minute. Basically, you're gathering the event. It's already a micro batch. And the other use case is basically just stream the data and save it to the sink. So traditionally, when I first started my streaming pipeline development, a lot of people were saying a streaming job should not do more than just bringing and saving, right? But no one actually is doing that, because nobody wants to just read the data and just store. This is on the assumption that you store the data into some place and eventually you do that, because the whole idea of streaming job is to get insights as quickly as possible, right? So in that case, if you are doing just getting it and then storing it and doing it eventually, you can better do in a batch job, right? So this is one of the cases which I observed. And the next use case is stream enhance using an API call or a static metadata. This was what I was referring. So you get some bunch of records, fields, and you wanted more fields basically, and you call an external API, and then you get the data. You enhance the existing API payload, and then you continue, right? And you also might have some static metadata where you want to have a lookup, it's like a map or something, and then you enhance. That's one of the use cases we have. Sometimes you also go with the joining of two other streams. When you say joining, basically it's actually coming from the input source side, not exactly joining here with a static metadata or something. And the last one is a stateful or stateless. So under these, you have like two flavors, which is the windowed operations, which means that you're actually trying to see what happened during the last 10 minutes for every minute. Basically, that window you defined as 10 minutes, and you actually have a sliding window. Every 10 minutes, it actually moves around, right? So here you need to know the state of what you are actually doing. It's not just you read a data, you forget it, you do something, you forget it. That's not the case, right? Here you have to wait for 10 minutes and then some execute on top of that. And then the delayed arrival. This is my favorite. So the reason is that a lot of times you don't end up with just reading and processing, right? You really depend on some other external event. Like out of the 3 to 4 use cases I worked on, almost 3 of them are actually depending on an external event which has to be arrived by the time this event is processed. Now here there is a heavy dependency that that event also should be happening by the time. But what if it happens late, right? So there are a couple of options there. You actually can store them in a quick lookup table. Maybe HBase can help. But the moment you go with that option, for every record you basically have to look up, right? Because you don't know whether it actually arrived or it's a late arrival or something, right? So there's a catch there. Or another option which I've seen companies doing is you can use a Kafka basically and configure it, or like you make it come back from the Kafka maybe after 30 seconds or something, or a minute or something, right? That's one of the options. This is the most preferred one because you can actually do a retries using Kafka, so you don't worry about getting it back. So that's one of the options. We can try it out, right? So it actually comes back, and there is only some certain amount of time you actually do that, because after a couple of hours, and if you think it's not coming within 2 hours, and that's the end of it. You don't basically go beyond that, right? So moving on to the next step. So those are the use cases for processing step, right? The next step is actually streaming sinks. So here you have multiple choices, but again, it depends upon the use case of your process, which is, so if it is just a stream and save, you have to depend on a database which is distributed and which you can actually scale and do faster writes. For that, basically, you have NoSQL options with like Cassandra and HBase, right? That's one of the options. And sometimes if you're doing a micro batch, you have an option that all of the data is available with you, and you don't need to write at record level. In that case, you can go with the Hive, Impala, or Presto. This is mostly for the micro batch, as we're talking about, right? But this has to be taken care with another problem, which is small files, right? If you go with this option. So you can get a SQL interface very quickly, but you will also end up with your small files. So these are the cases we need to consider. And the next option is the relational data store. So this may sound interesting because we're talking about streaming and we're talking about Oracle or MySQL. But if you're thinking of analytics, and if you want to store the data like for every 1 minute or like something like that, right? Then it's not a bad idea to actually aggregate. And once you aggregate, the number of records you can expect are very, very less, right? It's at a minute level, right? 30 seconds means basically like, the number of records are very less. So you can actually go and save it into, if it is an analytics use case, right? And then you can use that to pump up your visualizations. So that's one of the options you have. The next point you need to consider is the idempotency. A lot of times it doesn't come in direct flavor, but it actually comes as a side effect of some other issue, which is like a shutdown, which we are not anticipating, right? Or the data actually coming twice to your streaming pipeline, which you're not in control of, right? So these are the different cases you can expect surprises. Now, but if you have the same event twice, unless you have your sync taken up properly, you have to deduplicate at a very longer time, right? Because you never know whether the event is actually coming twice or not, right? So a lot of times you actually expect, because the row key, for example, the primary key of any NoSQL database takes care of that, because if you have the same event coming again, it actually just replaces that. So that they're using the feature of a sync to avoid the problems of deduplication. So it's up to you how you want. So some people, you actually can do the deduplication in the Spark or in a streaming job itself, right? But again, that takes resources. Like how much data can you go back to deduplicate? That's one of the bigger questions, and no one has that answer, right? You can come up, say that one hour or something, but eventually they will just say, can you wait for 30 more minutes or something like that. So it's always better, I see that, handling at the sync level rather than at the process level, right? And the last one is the API for saving. Now, when you choose syncs and the APIs to do your development, there is very little support when I started with the streaming job, which is HBase and Cassandra, right? Like the famous streaming framework is Spark, right? You have a couple of options when you're choosing a sync, which is Spark enabled, right? Streaming engine API, which means that they will actually work at the data frame level, right? You don't have any control at this point to handle connections or other things. It's definitely worth it, but you need to know how the exception handling is happening, how the connections are handling, and how it is taken care, right? Yeah. So if it gives you a good flavor, you can go ahead with that, or you can also use the plain simple JDBC. JDBC, I don't really mean a JDBC here because we are talking about NoSQL, but for example, if you have a Java API, a simple Java API for interacting with HBase or Cassandra, you can use that, right? But you have to take care of the creating the connections at each executor level or at each process level, right? You can't do continuous mode in this way because for every record you can't create one connection, right? So you need to understand exactly what's going on there to get this API, what API you are starting with, because a lot of times we see a couple of blogs, a couple of Stack Overflow reviews and see that they are doing something in that way, but we don't really realize that something is going on at the back end, right? For example, I was actually having this simple example for Spark API. It actually has JDBC where you can use at the data frame level, but it doesn't take care of transaction management. So one of the things you can use for Oracle is basically you can make use of transaction management, because if half of the records are failing, right, you actually do a rollback. But that is not possible unless you write your own JDBC code. Spark by default doesn't do that, right? So these are some of the catches you need to make sure that you're doing the things correctly under this category. Okay. So coming back to a generic. So now we are done with the individual stages of a life cycle, right? I just wanted to draw a couple of slides for the entire process, right? What are the resources do we need basically for processing a streaming job? The first one is a process, like it's mostly a Java process, JVM process. It can be one or many. Again, as I said, these can be executors in Spark or worker process in Storm, right? This is, I think everyone might be knowing it, but just want to make sure that we're having a checklist of all, right? And then we can have threads that can be one or many for each process. right? So this defines is in the cores in Spark and executors in Storm. And the last one is the memory, right? To perform basic operations, as we know, you need to have some in memory, right? But this becomes very important, especially if you are holding, like late data or micro batch, right? Because you don't know how much data you are going to store or process, right? This is one of the critical factors if you're working with the micro batch, which that is the reason why Spark executor, number of executors and executor memory is so important, because by default it is a micro batch, right? So that it actually comes to that hierarchy level. And as I was mentioning, graceful shutdown, this is also at the entire streaming job level, right? You actually can invoke a shutdown hook. These are some of the options I was looking at earlier. There's some of the blogs some people have done where you can actually invoke a shutdown hook based on an external event. The one option is like they are actually keeping a file in the HDFS, and there is a small job that's running continuously in the driver, and you continuously look at that file, and someone actually goes and removes that file, and your driver knows that the file is not there, so I have to actually shut down the job. It's a kind of crazy thing because you are actually having a infinite loop in the driver, and that itself is already a streaming job, right? So, but these are some of the options they were looking at. Or sometimes if you go with the Storm, it has a topology that is maintaining all of these things. So it's enabled at the framework level, so you can stop the topology to make sure that the current jobs are running and you're doing a graceful shutdown, so that the jobs are not in between. This is primarily important for data loss and to prevent any duplicates. And the last one is the testing and exception handling. Streaming applications are tough to test and debug. Everyone knows that, because once the stream starts running, you're at the mercy, right? So everything you need to do, you need to make sure that you're doing it before the job is actually started. But how do you do that, right? It again boils down to which use case you're doing, right? You need to understand when and how the jobs stop if an error occurs. Now, this actually can start at the driver level or individual process or the thread level, right? So what happens to my job when something happens at each of this level, right? So depending on the framework you are using, you need to go back and look how the framework handles the exception handling. That is very important. So sometimes you can actually continue the job in Spark streaming, for example, even if your tasks are having an error. That's one of the case. And the third one is my favorite. That's what I suggest to my applications, so to mock a master suite with a similar input rate as production. The first thing we generally do is you have a streaming job, and you basically spin up a streaming job. As long as it is running, you think it's good. But unless the data is processing at the same rate as production, your job is never stable, right? So that is very important. You can have the same data, but you can actually replicate the same input rate, right? So the proper modularization will help you basically to manage these issues, especially if you're interacting with a external API or small Java process, right? Those individual components can be tested without streaming job, right? So before you even hook up with a streaming job, you know how much load can it take, so that you don't debug it through a streaming job. You treat it as an individual component and you finish it up, and then you come back and integrate with the streaming job. That's one of the options you can choose, right? And the last one is the static versus dynamic resources, especially this is through Yarn, for example. So as you know, Yarn, Mesos, and Spark, they have their own options for resource management, right? So if you want to go with the static resources, yeah, then you are limiting the streaming job, and at the same time you are controlling as well. But if you go with the dynamic resources, your cluster can eat up all the resources which you are providing to the Spark, right? So you need to make sure you're already having portions of your cluster assigned to Spark jobs in general, right? And then maybe control at that level. Otherwise, there is every possibility that other jobs might be affected other than Spark in your Hadoop cluster. So that's one of the things you need to take care of, the testing and exception handling. That's it from my end. Any questions? As I said, right, yeah, I'm just learning So these are the ones, as I said, the pipelines which I learned mostly. The moment it's, I haven't tried quick answers, but I'm just exploring a lot of other options as well. But any other questions?
So, do you ever try like Kafka streaming? How capable Kafka streaming as compared to like?
Okay, so I won't say Kafka streaming because it's a streaming. You're using Kafka as a source, and you can use anything for the streaming job, right? Yeah, Kafka is the choice as everyone is using, right? You can also use Kinesis depending upon the use case, but Kafka definitely is used widely because of its reliability. So there's no question about that. But on the other side, the main point here is which streaming job are you using to read data from Kafka? That can have an effect.
Like Kafka streaming provides some of the.
You just say you're talking about K-streams? Oh yeah, K-streams is another option. That's what Spark streaming, Storm, K-streams. The K-streams is basically already giving you features, because it's linked with Kafka already, right? So you don't do a lot of things which you do in a Spark streaming, right? And you might have some extra features because it's already linked with Kafka. But again, these are all proprietary, so they give their own features if you go with K-streams, and you can and you have Kafka Connect basically to get the sources, right? So it's up to you. Yep.
So like the sliding table that you mentioned, so like ideally in a realistic situation, like how long that time is.
That depends upon your requirement, the first thing, and the second thing is your resources and memory capability. If you can hold the data for that long, you can actually go ahead. Like let's say if you have 8 GB RAM given for that executor, you have the capability to store that. Now if your records are smaller, maybe you can store 1 million, and if you are bigger, maybe you can store few 100,000, right? It depends upon memory.
Can you explain stream joins? Because go back to the slide of stream.
Stream processing?
Yeah, like there you say joining with other streams.
Yes. So basically the sources are both different. So you have two sources basically. You come from one Kafka topic and another Kafka topic. That's what we're talking about. Once you combine those.
So in that, if I'm trying to join with another topic, so should the processing stop until the...
No. So the processing won't stop, but basically your process in the streaming job can have an effect, depending upon what you're joining, right? Okay, cool. Okay, thank you. Thanks, everyone.